Good afternoon. So yeah, my name is Sam. I'm a principal developer at ShopRunner. We're doing cool things using Kotlin at ShopRunner. So if you have the opportunity, please come and join us. Today I'm going to talk about multi-platform support in Kotlin and specifically the state of testing when it comes to multi-platform. It seems quite opportune since 1.350 was released yesterday with tons of new Kotlin JS features. So JetBrains introduced multi-platform support into the Kotlin ecosystem in 2017 as part of the 1.2 release. It was new and very raw, but it was an excellent start. In the 1.3 release of Kotlin, multi-platform took another big step forward. It still remains experimental, but it's very usable, and there are a ton of projects out there that are now using it in the wild. So for those of you who don't know, multi-platform in Kotlin is the ability to write Kotlin source code but have the compiled output be in one or more platforms other than the JVM. So the way that this works is you define one or more targets in your build file, and these targets, as they're called, include the JVM, JavaScript, Android, iOS, native, as we've just seen, WebAssembly, and so on. So you'd write your Kotlin code as normal, but the compiler generates artifacts suitable for these targets. So for example, if you're defined targets with a JVM and JavaScript, then you would end up with two artifacts. One would be a set of bytecode classes, and the other would be a set of JavaScript files. So the reasons that multi-platform exists are twofold. One, that you can use your favorite language, which I would assume is Kotlin today, to deploy to platforms across your stack. And the second is that you can share code across these platforms. So write once and run anywhere, which the old timers amongst us will remember that was the killer feature that accompanied the launch of Java in the 1990s. So the way that this works is we have different source routes, as you can see. Platform-specific code goes into a source route with the name of the target, such as JVM main or JS main. And common source code goes into a common source route, common main or common test. Anything that's added to the common main source route will end up in the final artifacts of both the JavaScript and the Java outputs. So in other words, if we were to add a data class into common main, that data class would be available by code that's used inside each of the platform-specific source routes. So if we were writing a customer service application, we could have front-end specific code in the JavaScript source route, back-end specific code in the JVM source route, and common code such as domain objects in the common source route. So you can see in this slide an example of a multi-platform project Gradle file. Two targets are defined at the top, JVM and JavaScript, and the Kotlin multi-platform plugin for Gradle does all the kind of heavy lifting, gives us the Kotlin configuration block. It automatically creates a main and a test source set for each of the targets. So you can see there we've got the JVM main and JS main. There would also be a JVM test and a JS test, common main, common test. So if we want to do something like JSON parsing in the JVM project, we might add a Jackson dependency into JVM main. But on the JavaScript side, we would just use the built-in JSON support that's there in JavaScript by default. So now that everyone's on the same page with multi-platform, let's have a look at testing. So the current state of multi-platform testing is that we have test frameworks like JUnit on the JVM. And on the JavaScript side, there's the ever-popular frameworks like Mocha and Karma, Yasmin, QUnit, and probably two more have been invented while we've been talking. But we can't use JavaScript frameworks to test JVM bytecode, nor can we use JUnit to test generated JavaScript files. So JetBrains solved this by making available a library called KotlinTest, not to be confused with KotlinTest, which is a rudimentary test library consisting of 4 annotations: @test, @ignore, @before, @after, which do what you would expect, as well as some basic assertions. By writing tests using this library, they are compiled into compatible tests in both JUnit and/or one of the JavaScript test libraries. So you can see in this slide an example of a basic test using Kotlin.test, which will look familiar to most people. The fib test function would be compiled into a JUnit compatible test and into a Mocha compatible test. So here's an example of how we use a JavaScript test runner to execute any tests compiled to JavaScript. You can substitute any JS library that works in the same way as Mocha with the describe and it blocks. So you can replace that with Yasmin or Karma or whatever. There's also support for JUnit. So while this approach works in multi-platform projects, the downside is we don't have access to the powerful assertions or layout styles that we've become accustomed to when using a more feature-rich testing framework such as KotlinTest, or an assertion library such as AssertJ or Hamcrest. So the exciting news that is in the forthcoming 4.0 release of KotlinTest, there is now the ability to write tests across JavaScript and the JVM using a single powerful test framework. And KotlinTest plugs into both these ecosystems so that any tests written in the common source route will be compiled to both targets, and any tests written in a specific source route will be compiled into just that specific target. So now you can use the same library across an entire multi-platform project. Now, as I've just explained, the JetBrains Kotlin.test library also does this, but it's very basic, as we've seen. By using KotlinTest, you can have native support for suspendable functions. You can use the property test, the data-driven testing support. You can lay out your tests using the DSL that KotlinTest provides. There's inspectors for collection testing. You've got about 200 assertions you can use, including assertions from popular libraries such as Kotin and Arrow. It's just a nicer development experience. So now I'm going to show you this in action. So let's take validation. Validation seems like the kind of thing that you'd want to share across platforms. It sounds reasonable to want to use the same validation logic on the front end that you'd use on the back end. Maybe a form needs to show a user an error as they complete the fields, and once it's submitted to an endpoint, we want to make sure the submission is valid. So this kind of validation logic would live in a common source route, so it could be used by both the platforms. So I've created a sample application, and I've added two functions, validate email and validate social. Validate social will validate a social security number, and validate email obviously would check that an email was valid. And the validation logic for these today will be pretty simple, as that's not the focus. I'm just using simple regexes. So in the example functions, I consider a valid social to be one with 10 numbers in the format 3 digits, -2 digits, -4 digits. And a valid email will be anything that has an @ symbol and one character either side. Not robust enough for a real application, but plenty for our demo purposes. So the interesting part is that when implementing functions we declare in the common route, sometimes we need to delegate to platform-specific implementations. For example, until Kotlin 1.3.50 that came out yesterday, there was no way of doing a common duration or time API. They've literally just added it yesterday. So you would have had to drop back and had a JavaScript-specific implementation as well as a Java-specific implementation, like you still would do for data APIs. Okay? So although I don't actually have to do that for reg expressions, because there is a common regular expression library, I'm going to do it just for the sake of demoing two implementations. Okay? So here's the JavaScript implementation. And as you can see, this uses the native reg.exp object that's available in JavaScript. Anyone who's a JavaScript developer will recognize that. And the implementation is extremely simple. And there's the equivalent JVM implementation. So this time we're using the Java util regex .pattern class. But basically, the regex looks the same. And they're very similar. When you're writing functions that you implement in different platforms, you need to use the actual keyword when you actually implement it, and you use the expect keyword when you want something in the common source route. Okay. So here's an example of a test, and again, it's not rocket science, just a bunch of sample inputs and whether they test are true or false. And you can see that we're laying out these tests using KotlinTest's fun spec, which just gives you the test keyword, quite basic. Now, because this test would be located in the common source route, it will be included in the generated artifacts for each target. So we end up with a JavaScript version of this test and a bytecode version of this test. Then when we run Gradle check, each of the generated tests would be executed against the appropriate implementation. So the JavaScript tests would run against the actual JavaScript implementation, and the bytecode tests would run against the actual JVM implementation. One test file at compile time, two test files at runtime. So here you can see the output from running this through Gradle check. The tasks that actually do the heavy lifting are the JS test and the JVM test, as you can see there. You can run them individually if you just wanted to run on one platform, or Gradle check will run them both. The JS tests are executed using a normal JS test runner, such as Mocha, as we've described, and the JVM tests will run on the JUnit 5 platform runner. So if we were to go back and introduce a bug by breaking just one of the implementations, the combined test suite would still fail for one of those targets and pass for the other target. So there'd be an example of it failing in the JavaScript world. If I change one of the JavaScript regular expressions and reran Gradle check, you would have an output like this to show that the JavaScript test failed, but the JVM generated tests would still pass because that implementation was sound. So KotlinTest's flexible layout and powerful assertions are not the only part of the library that is now multi-platform ready. You can also leverage property testing. Now, this is just a lightning talk, and going into property testing in depth is certainly out of scope, but suffice to say, property testing is basically running a test with multiple randomly generated inputs, ideally inputs with edge cases that you may miss. So you can see in the slide a function called validate password. And this would test that a password is valid. And in this case, very simple, I'm just saying as long as it's between 8 and 16 characters, it's valid. So I want to test this on both JavaScript and the JVM for multiple combinations of passwords. So we could, of course, just test it with our own hand-chosen set of inputs. But really, we should test it for a lot of edge cases, including Unicode characters, hashes, pound symbols, whatever. And the property test function assert all will do this. What it will do is it will run that test inside the Lambda 1,000 times by default, and it will use the string generator, gen.string, to actually generate strings of length between 8 and 16. And those generated strings will include tabs and carriage returns and Unicode characters and all the things that we probably forget to test if we're doing it by hand. Each of those should pass as it fulfills the criteria of 8 to 16. And then the second test does the same thing but should fail because they'll all be between 0 and 7. So although the implementation here is extremely basic, and maybe property testing is an overkill for something that checks a length, but it does kind of show you that the principle is sound and that it will work on multi-platform. So before I wrap up, I want to show you how KotlinTest supports coroutine testing natively on both platforms. So as you can see in this slide, I have a function defined in common. It's a suspend function, so it needs to be executed inside of a coroutine. Now, if we were using a test library other than KotlinTest, we'd have to handle the coroutine ourselves. And on the JVM, we could do this quite easily. We could wrap the test in a run blocking call, and that would give us a coroutine that will block the main thread, which is fine, which is in a test, we don't really care. Once the coroutine completes, the test framework would continue, and everything's happy. But in JavaScript land, we hit a roadblock. The JavaScript coroutine module doesn't provide run blocking. There's no way to block the single thread JavaScript provides. So how do we do it? Well, KotlinTest solves this by running your test inside native JavaScript promises. And those promises are passed back to the JavaScript runner, such as Yasmin or Karma or whatever, for you automatically. So you can just have your coroutine directly inside the test. So this fetch user here is the coroutine. We're obviously using it. We're not calling run blocking. We're not having to launch anything. KotlinTest takes care of all that for us on both JavaScript and the JVM, which I think is really cool. Okay, so that's everything I've got for you. You can check out the code. It's all fully running on the KotlinTest repo. You just need to look for the project called Kotlin Everywhere Chicago. You can check that out. You can run that, and you can see everything that I've given you today working. So, and that's all coming out in the 4.0 release of KotlinTest. Any questions?
What about Moken?
Sorry?
What about Moken?
They're both?
Moken.
Oh, mocking. I haven't discussed mocking here. I don't use mocking that much myself personally. So I don't know if there's a shared mocking library. Mock-K might work in multi-platform, I don't know.
Okay.
I think you might have answered my question when you were talking about the one of your tests earlier, but like, the regex. What happens when there's a difference between like how JavaScript references say, well, this is just an integer, but when I get into column land as well as development, is there automatic conversions for the sake of the tests?
I think what you're asking is, if you had a double, how to represent it on different platforms. The Kotlin compiler takes care of all that for you. It's not really kind of related to the testing side of it.
Yeah.
But if you've got your normal Kotlin types, and they'll be mapped to whatever type on the platform.
Okay.
Anyone else? Titch?
When you were converting over KotlinTest to be multi-platform, how much did you actually have to add in
various platform support in terms of like implementations for JavaScript, etc., or was it mainly Kotlin specific only being standard operating?
I would say KotlinTest multi-platform is about 98% shared. You can look at the JavaScript modules, the JavaScript main, and see that there's a few functions in there. The biggest thing was ironically the durations, but now that as of yesterday's release they've got a cross-platform durations library, I can convert all that back to using durations again. And then obviously the coroutines thing was probably the big thing. If you want to do anything asynchronously on the JavaScript side, you've got to pass the promises back. So there's a little bit of like loop jumping that I had to go through in order to get that to work cross-platform. And since KotlinTest allows you to use coroutines in any side of any of the tests, and in any of the nested layouts, you could have coroutines at any level. That isn't actually supported on things like Mocha and Yasmin. You can only use a promise at the final level. You can't use it in the intermediate levels. So there's a kind of a lot of mapping I had to do to get that working. But other than that, most of it is just standard Kotlin code. It's quite nice actually. They've done a really good job, JetBrains. And Beck, you had a question?
Yeah, when you had the generated ones on screen, when it generates the random value to test with, does it use the same one for all the platforms that it's sent into, or could you wind up with different values?
Yeah, you could end up with completely different values because it's random every time. Something again on the roadmap for a future release of KotlinTest is to allow you to provide a seed. The Arrow library uses KotlinTest for all their tests, as you've probably seen. And that's one of the things the Arrow developers have asked for, is they want to be able to pass in a seed value, which is very sensible to do, and that way you can be, the 1,000 values you generate would therefore be the same 1,000 each time. But the idea is that if you have enough generated cases, it should flag up any bugs anyway. Anyone else? Okay, thank you very much.